Adding and subtracting matrices. That's what we're going to be looking at in this video. And just to do a quick recap, in the last video, we discussed what is a matrix, how do you determine the size of a matrix, and probably the most pivotal thing, the most critical thing that I mentioned in the last video is how do you determine when you add or subtract matrices? Like when can you do that? You can't just do it. It depends on the matrices that you're handed. That's what we're going to look at in this video. So let's just get right to it. Let's get down to brass tacks. In this example, we have 4 matrices, and what I would do is just write down right now, pause the video, write down all 4 matrices, because we're going to use these 4 matrices for roughly the first half to 2/3 of the video. Okay, hopefully you have paused the video and written the matrices down. Now we're going to do this example together. A plus C. What it's saying is I want to take matrix A, and to it I want to add matrix C. Now, we have to make sure that these 2 matrices are what? They are the same size, right? What is the size of matrix A? Well, it has 2 rows, and it has 3 columns. 1, 2, 3. If I'm going to add matrix C to A, C has to have the same size. How many rows does C have? 2. How many columns does C have? 1, 2, 3. It's 2 by 3. Are these 2 matrices the same size? Yes, they are. That's bad news for us. Why? Because now that means we actually have to do the problem. If these 2 matrices were different sizes, we'd be done. We would just write undefined and move on. All right. The fact that we have to add these 2 matrices together really isn't that big of a deal, though. All right, it's basically adding numbers. That's all we're doing, right? What is matrix A? Matrix A is 1, 2. It's 3, 1. It's 0, 5. And to that, we're adding matrix C, which is -3, -7, 5, -1, 2, 1. Now, for the first 2 examples, I'm going to be very detailed with what I write and what I say, but after that, I'm going to become more streamlined with what I say and what I write. But for the first 2 examples, I think it's important to be as thorough as possible. I'm sorry if you don't like that, but you're just going to have to deal with it. All right. The way that we add 2 matrices, if they're the same size, is we add corresponding elements. And what that means is we add things that are in the same location or the same position. What am I going to add to 1? Well, what's in the same position as 1 in the other matrix? It's -3. What am I going to add to 3? I'm going to add whatever's in the position in the other matrix that matches with 3. It's in the first row, second column, 5. So I would say, okay, 3 plus 5. 0 plus what? 2. All right, now let's look at the second row. I'm going to do 2 plus what? What's in the same position in the other matrix? -7. I'm going to go 1 plus -1. And then I'm going to go 5 plus 1. What this really amounts to is just doing basic arithmetic. So it looks like it's some complicated problem, but really it's not. We're just adding numbers together. So let's do that to get our final answer. 1 plus -3, -2. 2 plus -7, -5. 3 plus 5, 8. 1 plus -1, a 0. 0 plus 2, 2. 5 plus 1. 6. Boom, there's our answer. This problem's finished. I think you guys know what's coming. The next example, you are going to please pause the video and work it out for yourself. When I show the next problem, I'm not going to leave a lot of delay time for you to pause the video, so please do it right away. Let's do this. All right, check it out. First, I made sure that my matrices were the same size. They were. Matrix B is 3 by 2. Matrix D is 3 by 2. That means I can add these 2 things together. When I add them together, I'm adding things that are in corresponding positions, corresponding elements. 3 plus -3, 0 plus 0, 5 plus 5. All right, that comes from matching positions up. 3 plus negative 3, 0 plus 0, 5 plus 5. And then the same thing with the second column. 1 plus negative 2, 2 plus negative 4, 3 plus negative 3. All right? Now, in the next couple of examples, I'm not going to write this step out anymore. I'm just going to go straight from what I'm adding or subtracting to the answer. All right? Hopefully you got the same thing. 0, 0, 10, negative 1, negative 2, negative 3. If you didn't, call me over. I'll be happy to clarify why the answer is what it is. All right, next example. D plus C. Pause the video. Try it out. Let's do this. Holy smokes, check this out. The answer to D plus C is undefined. Why? Why is it undefined? The reason is C and D do not have the same size matrix. They're different size matrices, therefore you can't add them. And it's not really hard to see that. Look, let's pretend that we just went straight to adding them. Negative 3 plus negative 3, that would work. Negative 2 plus 5. But look at this. I still have something in a third column here, but I don't have a third column in matrix D to combine with that 2 or that 1. Can't do it. Can't add those two together. Answer's undefined. Hey, I'm kind of lazy here. I'm not going to write the word out undefined every time I need to. I'm just going to do U and D. I encourage you to do the same thing. I'll know you're saying undefined and not underwear. Use U and D. All right, next example. Here we go. C minus A. Oh, this one's subtraction. All right, then. Well, we still have to start off the same way. We have to make sure that C and A are in fact the same size matrix. So what is the size of matrix C? 2 rows, 3 columns. What's A? It is 2 rows, 3 columns, right? 1, 2 rows, 1, 2, 3 columns. Are the sizes the same? Yes, they are. So what does that mean? That means we can actually subtract these two matrices. But as you're going to see, we're not going to subtract them really. We are going to add them. First, let me rewrite the problem though. C minus A, and my matrix C is negative 3, negative 7. It's 5, negative 1. It's 2, 1. Minus, what is my matrix A? It is 1, 2. It is 3, 1, followed by the last column, 0, 5. Now, a lot of you like to use keep, flip, change, KFC. I think it's used as shorthand. I have a bad habit of using flip and change interchangeably, so you're going to have to forgive me for that in advance. I'm sorry. But I'll try to be consistent with keep, flip, change, because it seems like that's something that a lot of you are familiar with. Keep, flip, change. Keep what? Keep what? Keep the first matrix the same. Don't you dare touch it. You leave it alone. We are going to rewrite our first matrix. Negative 3, negative 7, 5, negative 1, 2, 1. Flip. Flip what? Flip me off? You better not. I'm just trying to better you. Don't do that. We're going to flip the subtraction symbol to addition. And to accentuate that, I'm going to do this in red. That's the flip part. Now, change. What are we changing? First of all, when you say you're going to change subtraction to addition, you're really changing the problem. You're really making a new problem. And to counteract that change, you have to change something else. And this is where the second matrix, whatever's inside of it, its signs are going to flip. If it's positive, it becomes negative. If it's negative, it becomes positive. We're going to have now negative 1. We're going to have now negative 2. It's like turning a light switch on and off. If it's positive, it's now negative. If it's negative, which we don't have any in here, but if we did, when we put it in this matrix below, it would become positive. So we're going to have negative 3, negative 1. 0 is neutral. It's not positive nor negative, so it stays 0. Now here's the thing that you should be very careful with. If you screw up one sign in your matrix, it doesn't matter what you do at that point, because the entire answer is going to be wrong. So you want to make sure that you get this part right. Positive goes to negative, and like I said before, if we had something negative in here in this matrix, it would now be positive. Now, let's add this stuff together. All right, and I think in the last example I was very detailed and showing everything step by step. I'm going to streamline this now. I can do this mentally, or you can use a calculator. 3 plus -1 is -4. 5 plus -3 is 2. 2 plus 0 is 2. -7 plus -2 is -9. -1 plus -1 is -2. And 1 plus -5 is -4. All right, that's our answer. We're finished. That's all there is to it. I know I went through that kind of fast, but I sometimes worry that I beat things to death unnecessarily. If you're confused about something, you can always pause the video and call me over and ask me. Please do that. Don't just continue watching the videos and continue to be blissfully ignorant. I don't mean that in a bad way. I'm sorry. That wasn't nice to say. I'm sorry. That was terrible. I'm just trying to say I care about you, and I'm trying to do things to help you, and I'm trying to try different ways to teach. And I don't want you to think that I'm just throwing you on the computers and you have to do this all by yourself. So please call me over. All right, here's our example 5. Pause the video, work it out, and then check your answer. Let's do this. Alrighty, take a look. Here's what I got for my answer. I got in the first column 6, 0, 0. In the second column, I got 3, followed by 6, followed by good old number 9. All right. How did I do that? First, I checked to make sure the matrices are the same size. 3 by 2, both are. Bad news for me in a way, because now that means I have more work to do. Okay, you know, life's tough. Get over it, right? 3, 0, 5 is matrix B, followed by 1, 2, 3 makes up matrix B. What am I subtracting? I'm subtracting matrix D. What's matrix D? Matrix D is -3, 0, 5. It's -2, -4, -6. I don't like subtracting stuff. I want to add. I want to do it my way. I want to add. So I change subtraction to addition, keeping the first thing the same. And then I flip the sign of everything in my second matrix. -3 became +3, 0, -5. What was negative became positive, 2, 4, 6. And then I just added corresponding elements. All right. I think you guys are doing really well with this adding and subtracting matrices. And now what we're going to do is take it to the next level because I think you're that good. And here's our next topic, where we're going to be using adding and subtracting of matrices. We're going to be solving matrix equations. Oh, I know you're all just, oh, that's so exciting. Yes, let's solve them. Absolutely. Let's do it. To solve a matrix equation, you're going to solve it in a similar fashion as you would if you were solving something like this. Let's say that I asked you to solve y plus, oh, I don't know, 2 equals 5. How would you solve that? Well, you would probably say, I would subtract 2 from both sides. And you know what? I think that's a good approach to take. That's exactly what I would do. So y would equal 3, would it not? We are going to use those same principles we have used for solving equations in the past to solve matrix equations. All right, so really, I assure you, you already know how to do this. Just have to believe in yourself, and trust in me. How are we going to solve this thing? We want to get this x by itself, this capital X, and that capital X is a matrix. How am I going to get that x by itself? I need to get rid of this matrix right here. It's just spoiling the works right now. I got to rub it out. I got to get rid of it. So to get rid of it, since it's being added to x, we are going to subtract it. We're going to undo what's being done to our x, and what we do to one side, we do to the other. Those are the two guiding principles of solving most equations. Undo what's being done to the variable, and what you do to one side, you do to the other. So I'm going to subtract off this matrix right here that was originally added to x. All right, now I've got an equal sign going. Equals what? Well, I've got 5, 7, and I've got -2, -5 on the other side. But what I do to one side, I do to the other. If I'm subtracting this matrix on the left, I need to also subtract it on the right. -3, 0, -2, negative 4. All right, now, what happens here on the left? These two matrices annihilate each other. They're gone. They're out of there. What am I left with on the left? I'm left with this big ol' X, capital X. Remember, that X is capitalized for a reason. It's indicating it's a matrix. Equals what? Well, what are we doing here? We're subtracting two matrices now on the right. I don't like to subtract matrices. I like to add. So I'm going to change it to addition. I'm going to have 5, 7. I'm going to have negative 2, negative 5. I'm going to change my flip. I'm sorry, flip. See there, I did it. Flip. I'm going to flip my minus to plus. And then I'm going to change everything that follows. Sign. Negative 3 becomes positive 3. 0 stays 0. Negative 2, positive 2. Negative 4 becomes 4. And now I'm just going to add corresponding elements together. 5 plus 3, I get 8. Last time I checked. 7 plus 0, I get 7. Negative 2 plus 2, I get 0. Negative 5 plus 4, I get negative 1. All right, that's it. So we're finished. What this is saying is the matrix that I have to add to this matrix in order to get that matrix on the right is x equals 8, 7, 0, negative 1. All right. Yeah, you know it's coming, don't you? Yeah, you know it. You can just feel it in your bones, can't you? Next example is for you. So I'm going to show it. You pause the video, you try it, and then check your answer. Let's get this done. Alrighty then. Here's what I got for my matrix X. In the first column, 0, 10. In the second column, negative 2, negative 4. How did I get that? Notice that it's subtraction here. It's X minus this matrix. So I'm not going to subtract it. I need to undo what's being done to X, so I'm going to add it to both sides. These two matrices cancel each other out because they're opposite matrix. They're opposites of each other. Right, well, meaning if you get what I mean. They're going to cancel out, right? They're going to cancel out. It'd be like saying x minus 2 plus 2, just pick something up, or x minus negative 2 plus negative 2. Those would cancel out as well. All right, then on the right-hand side, we add corresponding elements. 2 plus negative 2 is 0. 3 plus 7 is 10. Negative 1 plus negative 1 is negative 2. Negative 8 plus 4 is negative 4. All right, guys, that's it. That's all I have to show you. I hope you've enjoyed this video, and I hope you've learned something from it. And as always, keep up the great work. See you later. Bye.